And this leads us to look at, okay, would there be something similar which is this kind of more advanced spontaneous focusing tendency than this spontaneous focusing on numericity. And then we started to look systematically these topics. We first made that with younger children. We had this kind of situations that, again, this feeding task that these are brothers, they like very much bread, and they always do the same. They eat the same, they jump as high and whatever, so that the children knew that they are. And then we gave them, the researcher gave them bread from this plate, gave one piece, and then they say that unfortunately the bread is broken, but you have you make the same. And then we were looking if they give if they focus on just on a number, that they give one piece, or if they look the relational aspect, that okay, in order to make the same, they have to give two pieces of that. We make the same with rice, so that we had different sizes here, that the researcher gave with a smaller one, or the researcher gave with a bigger one in different trials, and then again we looked what happened then, and again the child had no idea that this has had anything to do with mathematics or numbers, and this was related in the very similar findings than the SFOR findings, that there were strong tendencies to pay attention to relations or not to pay attention to relations. Of course, there now it's a question that this already requires some skills that they have to be able to be, but I come back to that. Okay, this seems to develop by age, so that first students pay attention to numericity, and not first students pay attention to numericity, but then it goes down, and then only earlier in the beginning they do not pay at all in relation to the relation, but then it's improving, and then there are students who have some other which is not non-mathematical aspect. Then in a little bit older population, this relation is the same, so that this relational thinking, focusing on relation, is improving by age. But still, in the 9 years old, in this task, it was not completed. But we noticed that this is relatively easy task for 9 years olds, so that in our later studies we developed other tasks. But we already noticed that that when we measured these skills in the first grade, and then looked how they learned fractions on the fourth grade, there was this focusing on relations predicted fraction knowledge. And then we developed a new, more bigger longitudinal study on a little bit older students, and there we needed new tasks, and so I go to the tasks in order to be. This is our teleportation task. So and here the story is that in future there is a space station, and we have to send from the Earth things to the space station, and we need to that's very complicated, but fortunately a teleportation system was developed, but because it's a prototype, it's not completely reliable, that something happens in between. And then this is an example. These things were sent from the Earth, and these came to the space station. Please tell what happens. And that was completely open task. And then after they had explained that, then they gave a written answer to that, and we give this kind of figure that, okay, make use of the previous picture, and now these things have been sent. What comes to the space station? and then they had to draw it. And we continued it with more kind of naturalistic things, so that is many things change here, and but of course you can see that in all of them there's a kind of multiplicative change. They should see that there's one change which is stable in them, that all these things are in this case 3 times so many, or here they were half of the task which were sent. And this resulted also very stable results, that students in this task and then in our second task, where the story was that it's important to eat healthy food, and then we had different plates and they had to explain the plates. And again, if students reported the relational aspect, that how different things are related to each other, then they were scored as focusing on quantitative relations. So that we got a relatively high overall stability, the overall kind of reliability of these tasks. And then there's, of course, these are very much related to the mathematical skills. And we wanted to be sure that when we use measures of spontaneous focusing, this is a poor measure of spontaneous focusing, and that's why we use so-called residualized tasks, so that we explain the SFOR with understanding of rational number, that these relations, and then residualize them so that we got a poor measure of the SFOR tendency. And this now explains that when we looked at rational number understanding in a long-term measure, then and this is the latent core model, we see that there were 2 aspects. There was this residual SFOR score and non-verbal intelligence, which was measured with Raven matrix. These 2 predicted the level of knowledge and then how quickly it was developing this slope aspect of the development, so that it seems to be a very strong predictor. And here we see a kind of development. There was a reciprocal development, so that the conceptual understanding of rational numbers was the earlier SFOR was predicted conceptual understanding. Conceptual understanding predicted later SFOR, and again SFOR, so that this kind of focusing that we learn to see in our environment relations is a tendency where children are different, and if our understanding of rational numbers develops, our tendency to focus on all kinds of relations in our environment increases, and this again makes our rational number knowledge stronger. And this again have now leads to training, so that we have a large training program where we are training students to focus more on relations, and this is related to large teacher in-service training programs as well.